Today we're going to cover blended segmented threading.
My name's Glenn. I've been using PartMaker for, well, since 2006. Was an applications engineer for all those years. Previously, I started with the CAD/CAM industry back in 1984 doing tool and die design. So I've got a lot of experience in this. Now, the sample that you're looking at here is a very simple segmented threading. And in this example, we're doing a 1/4-20 thread. And so the pitch is a 50 thousandths pitch. Now, next line, I'm just going down the lines here. So user data conditions, when you're doing a segmented style thread, you're going to have to use a G32 style thread output. And for PartMaker, you can go to the setup dialog, go to user data, and there should be a checkbox in the user data for a G32 style threading. You'll see the little question marks beside them. If they're black, then it's going to give you information there. This is what you can do here. So if it's a canned output, you would get G76 style. If that is unchecked, you would get G92 style, but we need a G32 style thread. So there's the 50 thousandths pitch. So you'll see I have a line in front of my part at 50 thousandths and above my part at 50 thousandths. A segmented thread has to start at a pitch increment. And generally 1 will be fine. You may prefer 2, but 1 will be fine. You're going to feed across your part starting at the pitch. Your stock will index around, actually your machine will index to 0. You'll start your thread. It's going to feed across and then feed out of your part along 1 pitch. Now I put it up at 50 thousandths. You could do whatever you want. You could higher or lower as long as the thread insert comes out. I find it just easier if it's a 50 pitch, make it a 50 thousandths above. And we're going to do 3 segments on this. Now to get this to work out right, I'm going to take this line. This is my 50 thousandths in front, and I'm going to translate 42 copies. I know it's 42 because I've done this before. And I'm going to go a distance. I'm going to translate it 50 thousandths and vertically nowhere. So we're just going straight across. Click on translate and close. So now I've got these lines, and these will help me determine where to start and stop my thread process. So let's zoom in on this front section. Right there. So now I'll go to cam mode. Now you'll see I already have a facing process, my thread clearance and my cutoff already done. So we're going to concentrate on the threading process. So we're going to choose threading. We'll be outside, no chamfer. Pitch, this is just 1 divided by 20. Press enter and you'll bring up your threading tool. We only have 1 here, so we'll select that. You'll see the information is filled in now in your profile group. So the first infeed, if my thread height is coming out as 30, I don't want it to go in as 20, so let's say we'll go 12. The minimal infeed, if 5/10 is fine. Thread height, this is determined by a 61.34% of the pitch. So it's coming out as 30 thousandths, and let's say we're going to make this a little bit, we'll just go to 31 thousandths. In your part print, you're going to see a nominal value for the thread height. So there's my pitch. Infeed angle is set to 0. The clearance is going to be 50 thousandths above there. Acceleration distance is 0. So with a segmented thread, infeed angle is 0, acceleration distance is 0. We'll go to thread options. buttons. With this radio button here, you'll see the variable in feet based on a constant volume or standard G76 style code. But what I want to determine how many passes. That's just my way of doing it. I prefer it that way. I'm going to get 6 passes and 1 spring pass. And we'll name this one first thread. First thread. I'm going to go define this. I'll take define profile. I'll use the closest intersection. I'm going to start here. That's where my thread's going to start. That's the 50 thousandths in front. I'll go to this point. There it is. And then I'll feed out 1 pitch and up 1 pitch. Put that tool away. Now let's verify that. Let's make sure it looks like what I want. So it's feeding in the 1 pitch amount and feeding out on the pitch. Well, now I need to make the second thread, so I'm going to make a new color for that one. Let's go with dark blue. And pan that over. So now my second thread, I need to start at this point. That's 1 pitch away, feed down the 1 pitch, come over and out again. So the reason we're doing this is that my guide bushing is only going to allow so much travel before the stock comes out of my guide bushing. So we're going to duplicate this process. So we can select it, do a right mouse click, and duplicate the group. So now it just makes a copy of this. So all the information that I've put in here is duplicated. And we can change the name. It's clearly not the first thread, it's the second thread. And we can get rid of the copy information there. So now there's my second thread. Close. Since I want to change that color, I can either select the color up here and click on the circle, the color circle, or I can right mouse click and I can say change group color and pick blue. I find it easier to just click on the other circle. So now I want to define this again. I'm going to start at this point, come down to this point, come to this point, and this point, and put that tool away. We'll verify this one. See, it feeds in and out on the pitch increment. Well, now I need to do this next section. So pan over. And we're going to go duplicate this one. Change the name. Reason I duplicate this, anytime you make a new one, you have the chance that you're going to make a mistake. So I try to duplicate these to keep these the same. So now I have my third thread, and I'm going to change that color. We'll make that one, let's do green. So now my third thread, I'm going to go from 1 pitch before down to the intersection. And here I can just come to here and come out, or yeah, we'll do that like that. And we'll verify this one. So now you have 3 segments in this, and I'm going to put these into the correct order. So we'll take this one, and you can just hold the left mouse button down, drag and drop these into the order you want them to be run in. So now I've got my program there. We're going to generate our process table. Take a look at this. So I've got my facing process. Now these are out of order here, So I'm going to take this one, move this up, move that up. So now it's faces, first, second, third. There's my thread clearance. There's my cutoff process. Now, on the first process here, which is my facing process, you'll see I've put the eject on. You do not need to have an eject in your program, but if you don't have one, it's going to prompt you and saying, do you want one? Rather than go through the prompt, I put that in there. On the cutoff process, I put this as a follow support, and I had it move up 2.5 inches. My part is 3 inches long. And so now let's go to simulation. This is basic sim. And we have the speed of 1. We'll start this up. I'm going to pause that. I want to move in a little closer. There we go. And we'll restart that. So it faces, does the first thread, second thread, third thread, does our thread relief, and our cutoff. And if we show our finished part, you should see that these blend perfectly around. You should see a line where they start. So that's a single point, or a thread tool with a single thread but segmented. Now you can, since this is a very simple part, you can set this up also to do a double lead or a triple lead, whichever lead you need. And to do that, all you're doing is going to thread options, opening up your first thread process, put in the number of leads you need. We'll make it a 2 lead. And then you take the pitch amount and you multiply that by the number of leads. So 2 times, and if we click the apply button, you'll see that comes out to 0.1. Everything else stays the same. And we can go to the second thread. And this time I'm just going to say it's 0.1. And 2 leads. And the third thread, same thing, 0.1 and 2 leads. I'll generate my process table again. Nothing's changed here. In simulation, though, what we'll see is that we'll do 1 lead and then the second lead for each recurring part. So there's your first, second, our third. So now, if we zoom in on the front, I probably should have picked a different color, but you can see the start of the first lead and the second lead. So a simplified version of this with a straight piece, with a very simple threading process, is very easy to do. I don't think any of you will have any problem. When it gets out of the simple, though, that's where the problem starts. So let's go to the next part. Now this is a much more complicated part. This is a bone screw, we've got a chip break, we've got the segmented thread. So let's take a look at how this is done. So in this, we do a, let's show this and we'll minimize this. All right, so in this, we do a facing process, not too complicated here. We have to do a turn. So that's going to feed onto my part and out. Our first thread, you'll see you have your pitch amounts. Here we have a 144 and a 72. we're feeding up from 72, coming into our, I guess I'd say this flat portion of this, and feeding out. So now we have our first infeed, minimal infeed thread height, just from the bone screw itself, is 39.4. My pitch, 72. Infeed and acceleration are set to 0. If we verify this, what we have done differently in this is we've used a custom thread shape on this. It's slightly different, but the only thing that is really different is if you've used the user-defined tool shapes, you create a copy of your tool. We'll go to a full view of this. So in this, we've defined a tool shape that matches what's going to go into my machine, and we set the distance in front to get to 0. I called it custom thread, and you'll see this shape is right there, the 3D shape, just like that. Now, the 57.5 dimension, from 0, where we're measuring 0 on this tool, that is the amount of material, or I should say the leading edge of this tool, that is set in tool properties here. Now, depending on what type of machine you have, you may have to output a G50. That would be done with a checkbox there. So now we'll go back to cam mode, back to this first thread. So that just fed up and out. You'll see the second thread. Well, we do a turn here in this particular version. Comes in, and then our second thread, once again, just starts at an increment, 1 pitch away and 1 up, feeds across and comes out. And turn 3, we have to turn this back section out, and then a third thread. Now in the third thread, you'll see that this is tapering out of the bone screw. All we're doing is we create a line across here. And this distance between is just offset 39,004/10. If we verify that one, works the exact same way. We go to our process table. Now the difference, we do have a chip break in this. Let's go to simulation. Zoom in and start. So it still faces and turns. Does our chip, or rather our first thread, does our chip break, and second thread, and eventually third thread. If we show our finished part, there's our finished part. And once again, you can see where this comes across. So single point threading is really quite simple. You're just doing that 1 lead in and 1 lead above. Where it gets complicated is when you go to segmented thread whirling. So let's go here to the next one. That's the exact same part, but this is done with a whirling head. So let's go close now. So in this, we do a turn, just like we did in the other one. Nothing looks different there. First thread. So now this, we're going to go show just that one work group. So now we have this, we have a lead angle, or rather a 72 thousandths, that's my pitch amount. We have this 144. So in this, when I open this up, now we're doing a whirling head. You can set the toolpath options over here. No ramp, ramp in, ramp out, or both. We left this as ramp out. We determine our thread height, still 39 and 4. Our pitch in this is 0.144. Clearance is set, face clearance is set. Acceleration distance, in this particular case, since I am starting at 0, I can put in the acceleration distance and I can ramp out at an increment of my pitch. Notice there's no information down here about thread options. So this particular one has a 2-lead thread. So to do a 2-lead thread, I'd have to make a duplicate of this. So we're going to close this. We're going to verify it. Good one. So you'll see it's very similar. It's starting 144 in front, comes across, over, and feeds out on my half pitch. Second thread, it's the same location. Starts still at 0, comes across, comes out. But in this example, so the thread height is the same, the pitch is still 144, face clearance, acceleration distance is now half. So we are at 180 away, and the ramp out is still the same. So here we're starting at the half pitch amount. So this is a 2-lead. So these threads are 180 out of phase. We do another turn, and then there's turn or thread rest apart. Now in the thread rest apart, there's actually a chip break in here. So you'll see the mill goes across. So in this case, my first thread, the rest of thread, what I've called here, is going to go across the entire length of this. So it would deburr and finish the thread. You'll see that starting at 144. This one, doing the same path, is now starting at the 72 increment. So what's this look like? So we have this information. There's that milling that's done there. Face and turn. First thread, second thread, mills. And then it's going to do the rest of the part here. And finish that part. And if we stop this and show the finished part, there's that finished part. Now in this, since we ran actually 3 different threading passes, 4 threading passes across here, you'll see that some of these are blue, some of them are a mix of green and blue, which is what you would expect since I'm using different colors going over the same area. So you'll get this kind of looks like a zebra pattern here. One last one. This is a very complicated one, probably one of the most complicated threading processes I've had to do. Usually I don't need help, but on this one I did. This particular part, although it does have a hole drilled through it, is difficult because the customer wanted to use a double thread insert. So it's cutting 2 threads as it goes down. The pitch is 210. And let's go to my other screen. We're going to zoom out. There's a lot of text here, so it does kind of scroll a little bit wonky. There we go. So when using a double thread insert, I don't know if any of you use them, but they're hard. The first thread will have to feed out of material. To finish the thread, you need to make an additional cut at the end of the part. So this double lead thread or tool is going to come down here, but when it feeds out, the lead tooth does not cut. So you have to create an additional pass back here to start this. So I have a couple notes here. On this, I set these up to start here. And you run into the issue of the double lead tool being out here. And if I go to camera mode. So the thread height was 40, the pitch 210. Acceleration distance in this case is 0 because I actually programmed it in to start at the pitch amount. I verify this one. So you'll see it starts here at the 210, feeds across, and feeds out. The second and third thread, they're going to start, and it's going to be, you see your acceleration distance is 0, the pitch is still the same, but they're starting at the half pitch amount, the 0.105. Let's go to a full view, and I'll verify that one. So now this one comes here, you have your chip break that's milled in. Third thread is actually coming across the entire piece and feeding out. But when it gets here, see how it's come out? It's no longer cutting in here. So we have to make a fourth thread, and the fourth thread starts on the half pitch, and it has to start on a horizontal line, which is what was driving me crazy. I wasn't having it start that way. So let's go take a look at this one. Yes, I know. So it does turns the front, does our mill. And turns that part. Complicated part. Remember, start easy before you go getting more and more complicated.
There's one question here. How would you stitch a compressive or expansive thread, such as G34?
So in my thread options here, do you mean like a lead variation rate, G34? Yes, okay, I thought so. All right, two things. One, you'll see the little asterisk here, used only in can cycle if required. So you're going to have make sure that that is actually set up in your post processor, so that when you do this, that option is going to be in the post. And when you go to like your setup dialog, in user data, there'll be an option here for that variable lead. Hopefully that answers your question. So just like we turned on a G34, you would somewhere have a G30 or a G32, you'd have an option to do the G34. Assuming the option exists, yes. You'd have to talk to the post developers to make sure it's in or could be put into your post.